Hello and welcome to the special meeting of the Sustainability Commission for January 8th, 2026. Meetings are broadcast live on Glendale TV, viewable on Spectrum Cable Channel 6 and AT&T UVerse Channel 99. Meetings are also streamed on high definition on the city webpage, glendaleca.gov/live, on youtube.com/myglendale, and on Apple TV, Roku, Amazon Fire, iOS, and Android devices using a free app called Cablecast and choosing Glendale TV from the menu. Meetings are also archived on the city website for viewing at any time at glendaleca.gov/agendas. Please call 818-548-41364 for program schedules. For public comments and questions during the meeting, please call 818-937-8100. Public comments for a specific agenda item will be taken when the agenda item is discussed. If you have questions about matters on the agenda or requests for assistance, please call the city clerk at 818-548-2090. Okay, can we have the roll call?
Thank you. Now I'm going to conduct a roll call. Commissioners Bazemore.
Here.
Artunian.
Here.
Chakarian.
Here.
Vice Chair Pinkerton. Chair Werner.
Here.
Ex officio Fay.
Here.
Ex officio Park.
Here.
Thank you. Now, please, let's do Pledge of Allegiance.
Please stand. Okay. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
B, land acknowledgement.
We would like to acknowledge that we're holding this meeting in the city of Glendale in Tovag Nar, the home and traditional lands of the Gabrielino Tongva people. We would like to pay our respects to the elders, both past and present, and to the Gabrielino Tongva communities who continue to be stewards of this land. Glendale's history did not begin with colonialism. Indigenous communities have lived in this land, or in this area, and been stewards of this land for hundreds of years and numerous generations. The Gabrielino Tongva community continues to grow and flourish. We encourage our audience to learn more about the indigenous communities in California and beyond by visiting the eglendale.org/Native American website for a list of books and resources. Thank you.
Thank you. Item C, posting of the agenda. The agenda of the January 8, 2026 meeting of the Special Sustainability Commission was posted on January 2, 2026 on the bulletin board outside City Hall. Item number 2A, approval of the minutes of the Commission special meeting held on December 15 and 2025. May I please have a motion and second?
Did anyone have any amendments or corrections to the minutes from last month?
No. Move to approve.
Do we have a second?
I'll second.
Okay, roll call, please.
Commissioner Bazemore,
Yes.
Commissioner Kartunian,
Yes.
Commissioner Chakarian,
Yes.
Vice Chair Pinkerton, Chair Werner.
Yes.
Thank you. Item number 3, board member and staff comments.
Okay, do we have any comments? We do have a presentation to give, so we can do that first, if everyone's okay with that, and then do the rest of the comments. Okay, great. So it is my huge honor to nominate a recipient of the Environmental Stewardship Award to Stephanie Landrigan. She is a distinguished landscape architect and longtime champion of protecting urban woodland tree canopies throughout California. As director of the Landscape Architecture and Horticultural and Gardening programs at UCLA for 17 years, Stephanie has educated aspiring landscape architects in environmental stewardship areas such as water conservation design, pollinator habitat creation, and green stormwater infrastructure. Stephanie is currently director of Altadena Green, where she has helped save countless trees after the Eaton fires. Preserving fire-damaged mature trees will help restore the character, heritage, and culture of Altadena as they strive to rebuild their community. Stephanie served for 9 years as chief landscape architect for the Mountains Recreation and Conservation Authority, where she applied scientific principles to advance wildfire resilience in wildland-urban interfaces. Stephanie advocates for sensible science-based policies that increase fire safety while preserving natural resources that protect populations from the impact of climate change. Here in Glendale, Stephanie has served on the Planning Commission, Design Review Board, and Historic Preservation Commissions. She is currently advocating within the city and the Southland for local control of Zone 0 implementation. Achieving this goal would enable cities to develop environmentally responsible, nature and science-based solutions that consider local specific climates and risk factors. So this award is presented in recognition of Stephanie's exemplary and tireless endeavors to preserve urban tree canopies, inspire sustainable landscape design, and promote nature and science-based approaches to fire resilience. The City of Glendale Sustainability Commission appreciates your efforts, which will benefit residents in Glendale and beyond for generations to come. And I'd like to invite Stephanie to come up to the podium. Then if we could gather and to maybe take some photos with her, that would be great. Yeah.
Nice job,
Most people we've had since the AstroTurf. Award. Crowd in a little.
Squeeze in.
Got to do the sideways. Thank you so much. Thank you so much. Thank you. Thank you for everything you've done. Thank you. Wonderful.
Did you want to give Ms. Landrigan the opportunity to say
Yes.
something?
Yes, Stephanie, would you like to say a few words?
Thank you. Thank you very much for this recognition. It's lovely to have the work that you do, that is your passion, honored. And I love Glendale. I've been here for, I can't even remember now, 34 years. And one of the things that has always been important to me is how beautiful our city is and how treed we are. So thank you for letting me lead I would say, a passionate way forward so that we can continue to self-regulate and self-govern when it comes to our natural resources. And you guys are doing a great job. Thank you very much.
Oh, thank you.
Chair Werner, we have one more speaker card. If you
Okay.
Councilmember Brotman.
Okay. Welcome, Councilmember Brotman.
Thank you. I'm not used to being on this side, but, and I apologize. I lost my voice. I think I may be coming down with a cold, so I'm wearing a mask to protect everybody. But I found out about this award about, 30 minutes ago? I was at home, but I thought I need to come down and be here because this is so well-deserved. Stephanie does so much for us, but I'll just mention, one recent thing, which is that she brought a really urgent issue to my attention and to the attention of the entire council with Zone 0 rules that were being developed by the Board of Forestry. And this is something I would not have been on top of. And had she not brought it to us, we would not have acted. But the council did have a discussion on it. And Stephanie provided a lot of the information that was the basis for that discussion. And we ended up taking a position as a council, putting in our opposition to some of the more drastic ideas that they were presenting, and our support for some alternatives that Stephanie had suggested were good ones. And I'll hopefully get an update from her on anything new that's happened. But I just want to say it's such a great example of somebody from the community that really cares about our trees to come and bring it to us and engage us and get the council to do the right thing. And I know she's working on a lot more. It's not just the council here in Glendale having an opinion on it, but it's all the work that she's doing at meetings with the Board of Forestry. So I want to thank you for that. I really appreciate the work she's done, and this is so well deserved.
Thank you. And we will be having a presentation from Stephanie at next month's meeting, so hopefully everyone will get a chance to catch that.
Next item on the agenda, item number 4, all communications. Discussion is limited to items within the jurisdiction of Sustainability Commission. Each speaker is allowed 5 minutes. Sustainability Commission members may question or respond to the speaker, but there will be no debate or decision. The matter may be referred to staff for investigation and report. Chair, we do not have any speakers or callers. And next on the agenda is the auction item. Item number 6, reports and information. 6A, NASA's orbiting carbon observatory missions.
All right. Good evening, Commissioners. This is our third time trying to have this presentation. As you all know, Commissioner Bazemore requested for
All right,
us
if
to
I could
hear.
interrupt just for a second, was there a verbal modification of the order of the agenda?
I was emailed in advance and asked if they could put this at the beginning.
Okay,
but-
And then-
for the
Yeah, we
benefit
should-
of folks that may be watching, it would be good to note for the record that item 6A will be taken before item 5A. Thank you.
Yes, the speaker requested to go sooner, so they didn't have to wait for the duration of our business.
Yes. And we will be hearing from the speaker who's on NASA's Carbon Observatory mission from JPL.
Thank you, Nora, and thank you to the entire commission for providing this opportunity, and especially to Commissioner Bazemore, with whom I've had discussions previously. So let me just go ahead and share my screen. Can someone confirm that you can see the slides? Fine.
Yes.
Yes.
Okay, great, thank you. Okay, thank you. Again, good evening, everyone. So it's really a great honor for me to be present and talk about the NASA's Orbiting Carbon Observatory missions, which is run at the Jet Propulsion Laboratory. Now, before beginning, I do want to mention that this is what I'm going to talk about, these missions. This is like a huge team effort. And I'll give a shout out of some of the members that we have on the team at the end. But this really takes a village to run 2 big missions that are taking very important critical data. And also, I apologize that I cannot be there in person, but I do have my email ID and everything at the end. And so if there are questions that come up later on, as you later on get a chance to look through the presentation, then please feel free to reach out. So what we are trying to do here, kind of wanted to just take a step back for everyone and think about the Earth as this really complex interrelated system that we are trying to understand. I mean, we live, we breathe, and we do all our work here. But in general, there are just so many different processes that are continuously happening. I mean, from the fact that we are getting the radiation from the sun to sort of that has an impact like on the clouds and the rains that are falling to like, let's say, volcanoes, how much emissions we are releasing from our cities, as well as like how the plants and the ocean, all of these are kind of working together in tandem. And in order to understand all these different components of these different processes, as part of NASA, we have this huge system of sensors, or what we call a satellite missions, that are flying that take observations of different components. I mean, this chart is kind of like actually really, really frightening, or when you look at it, but all of these different components are occurring or working in such distinct ways that we really need measurements for each of them, but then we also need to take a step back and understand all of them in context. Now, what I'm going to talk about today are primarily OCO2 and OCO3 here, which are NASA's prime carbon monitoring missions. But I do want to give a shout out to all the missions that you see highlighted in the pink boxes that are operated or run out of JPL for NASA. So certainly want to make sure that we recognize those as well. Now, the Jet Propulsion Laboratory that I'm sure most of you are aware of, or all of you are aware of, in La Cañada Infantry, just north of you all. JPL has been part of NASA for a long, long time. We are actually an FFRDC, so we are managed by Caltech. But over the years, there have been several key technologies that sort of have flown into different NASA missions. And this is just like a snapshot, at least for the different Earth science missions that NASA is flying. Again, referring to the previous chart, there are missions that use technology related to the radar or to spectroscopy or to like location, GPS and timing. And these sort of like are part of different capabilities that we have at JPL that then feed into the NASA missions. Again, just to kind of collapse things, I'm going to be primarily talking about these two missions down here, OCO2 and OCO3. And so what OCO2 and OCO3 really measures or really tries to understand is this component right here, the carbon cycle. And the carbon cycle, again, it's not just working on its own, but really it is connected across all these different elements of the Earth system. So you might be thinking about like, what is the carbon cycle? Let's say I've never heard about that before. Well, the carbon is really the building block of Earth. So it's kind of all around us. We are made up of carbon, we eat carbon, we live, breathe carbon. And what it really is, or when we talk about the carbon cycle, so from a scientific community perspective, what we are talking about is the exchange that is happening between different components in the Earth system. So for example, when we burn fossil fuels, or when we are just almost at the cusp of 1 year anniversary of the big Eaton Palisade fires, like when those fires happen, those release a large amount of CO2 or carbon dioxide into the atmosphere. On the other hand, our trees, as well as our oceans, those tend to take up a lot of carbon from the atmosphere. And so it's this continuous exchange of carbon that is happening across all these reservoirs. That is what we are interested in tracking and better understanding. And the Orbiting Carbon Observatory 2 and 3 missions, those primarily measure the changes in CO2 concentration in the atmosphere, but then using that data, we can better understand how the flux exchange is happening across these different reservoirs. So now, what is OCO2 and OCO3? So OCO2, or the Orbiting Carbon Observatory 2 mission, this is one of NASA's dedicated missions for monitoring atmospheric CO2. We were launched back in July 2014, and we are still flying. The instrument and the spacecraft are in great health. And so we now have a data record that spans over 11 and plus years. We are on a particular orbit, what we call as a sun synchronous orbit, that allows us to take measurements from pole to pole. So we get this pretty global coverage across the entire Earth. And we have different data types, and I'll be talking about them in a little bit more detail. We also take observations in different modes. Now, from the spare of OCO2, and when I say spare, I literally mean the spare, because this was the second backup copy that we had. That's where OCO3, Orbiting Carbon 3 Observatory, was born. And so the instrument is essentially the spare of OCO2, but instead of, again, launching it into an orbit that takes the same measurement, what we did was put it on the International Space Station. And the International Space Station, that is flying 400 kilometers above us. And again, that gets a global picture. But however, the way the orbits for the space station work is that we only get to see from 52° in the north to up to 52° in the south. So we do miss out a lot of for OCO3, the data does miss out a lot of the very high latitude Arctic, like Alaska, for example. And OCO3 being on the space station is actually almost works like a hotel where someone needs to check out of the room for some other mission to go in and operate. And so there was a period between November 2023 to July 2024 where we were actually removed, put in storage. Another NASA payload completed its nominal mission, and then we were reinstalled back in July 2024, and we are continuing operations since then. So this is sort of how the global data, this is just an animation. This is like actual data that's being taken by OCO2 and OCO3. This is a 7-day aggregate, so showing the data that's collected over 7 days. But this is sort of the type of coverage that we get across the entire globe. Again, OCO2 provides this entire pole-to-pole coverage, whereas with OCO3, we are just seeing a truncated portion of the Earth. And later on, or shortly, I'll be talking a lot about the data that we collect over the Los Angeles basin, sort of looking closer to home. So OCO2 has that global picture and collects data, looks at pole to pole. OCO3 actually carries a very unique observing mode being on the space station. And this originally came about that we had to make some innovation to make the instrument work on the space station, but it actually turned out really helpful. And in this case, we call this particular observation mode known as a snapshot area mapping mode. I know that's a handful of term, so I'm just going to say SAM mode. So in the SAM mode, what it allows us to do is zoom in over a particular target location. So in this case, we are looking at the Los Angeles basin, and then collect very high density data over this particular domain. And so I've kind of put in some markers here, for example, where JPL is, downtown LA, and so Glendale is sitting right kind of around here in the middle, assuming you can see my mouse or cursor movements. So we kind of get this very high density data over a particular location. And there is no limit to how much of this high density data we take or which cities or locations we target. We can do as many of them as we want. And we have been looking at Los Angeles basin since the beginning of the mission back from 2019. This is just like, this one is just one visualization on one day in February 2021. This one just shows some of the other data sets that we have collected. So one of the questions you might have is that how do you even measure carbon dioxide from space? This slide is a little bit technical, but let me just like walk you through it. The way the satellites work is that they are essentially almost think about like carrying cameras on board. It's actually what we call as a spectrometer, but in a sense, what it is doing is like a camera on board that is taking measurements of the reflected sunlight as it bounces off the Earth's surface. And then as the satellite is flying over, then on the instrument we have, or within the spectrometers, we are able to actually look at the molecular fingerprints of how much CO2 is in the reflected sunlight. And we then back calculate the absorption levels, and that basically then tells us the amount of carbon dioxide concentration that you have in the entire path that the sunlight traveled through. So that's sort of the very basic principle. As we are kind of staring down at the ground, I wanted to draw your attention to this picture in terms of how big our data points are. So each of the dots that I was showing in the previous, any of the previous animation, each of those dots are roughly like 2 kilometer by 2 kilometer. And so I was actually previously, I think when I was preparing for this meeting, I was looking at like the area of Glendale, which I saw somewhere on Wikipedia was roughly around 80 kilometers square. So roughly, let's say for the city of Glendale, you could like stagger 20 of those data points together to get an understanding of the CO2 concentrations within that region. Now, this data that we take from the satellite, we actually take a lot of effort in making sure that they are of extremely high quality and accuracy. And so this data are heavily validated against independent data. We do this by actually comparing our data against a bunch of different ground instruments These are located in all these red dots that you see across the globe. And actually, one of our closest instruments that we have is at the Caltech facility in Pasadena, where on top of the Geological and Planetary Sciences building, we have this dome, which actually has one of those ground instruments. And so then every time the satellite is flying over, we kind of stare at this particular instrument, the roof is open, and then that's the way that we are able to validate our measurements. We now have, I'm really proud to say that OCO2 and OCO3 data now have errors less than 1 part per million. The CO2 concentration right now around the globe is around 420 parts per million. And so we are precise to within 0.25% of the data, 0.25% error. And then between the two instruments, we actually have pretty good agreement. So they are within actually less than half a ppm. Whenever I do all of these discussions with different people, always there's a question about so what do you mean parts per million? How do I even wrap my head around that? And so this is a really cool sort of figure schematic that was put together by the NASA climate team a few years back, which is can you tell the difference between caffeinated coffee and decaf? I know I cannot. I don't know if you all can, but if you can tell, then you have detected a concentration of 400 parts per million. And that's the amount of CO2 or carbon dioxide that we have in the atmosphere right now. And with OCO2 and OCO3, we are able to not only detect that concentration, but do so with an accuracy of less than 1 ppm. So we can imagine how accurate and precise these measurements are, because that's really what enables some of the big science advancements that we have. And really, in a way, the OCO2 and OCO3 missions, these two missions from NASA, they have revolutionized our understanding of the carbon cycle. As I mentioned, that we have a really small footprint, only 2 kilometer by 2 kilometer for each data that we take, extremely high accuracy and precision, global coverage, and we now have a pretty long time record that we are able to look at. I'm not going to be able to walk through all of the different science advancements that we have had, but in terms of just understanding carbon cycle science or understanding the exchange between those different preservers, we have had, the data has been used to look at everything from how the ocean responds to different events, how land, the biosphere, the trees around us, how they are responding to different extreme events, floods and droughts and wildfires, etc., as well as how much of emissions are happening across the globe from megacities and power plants, etc. And I have links for the main website later on, and there is list of very detailed scientific publications and other peer-reviewed papers that have come out using the data from these two missions. But I did want to show one example of some way in which the data is being used over the Los Angeles basin. So I showed you all this type of figure earlier on the data that we collect, let's say, over Los Angeles in OCO3 snapshot area mapping mode, so that high density mode. In this mode, if you look at the CO2 concentrations, that's in the color bar here, we can see that there is this higher concentration. So that's in yellow, which is on the higher side, pretty much from downtown LA all the way up to Long Beach, the port, as well as typically we also see some high concentrations around the Los Angeles airport. But then as we go out more into the mountains, at the background, the CO2 concentrations tend to actually gradually taper off. And we see this pretty routinely, these hotspots between the downtown and the port area pop up. These observations can then be used to estimate something like what we call as annual emission estimates that are happening from the entire Los Angeles basin. And I'm showing here one example for Los Angeles. We do this for multiple cities around the globe. And I've shown also an example for Washington, D.C. But the green bar that you are seeing here, so the green and the orange, those are estimates that are coming from other independent data sets. But then we can use the satellite measurements to come up with our own estimates of how much CO2 emissions are happening. And that's sort of shown in the gray bar here. And in the case of Los Angeles, as we see that all these three bars kind of pretty much agree with each other pretty well. So that's certainly a good sign. That's not necessarily the case for something like Washington, D.C., or many other cities across the globe, we have seen that the independent data sets that report emission estimates, sometimes they do tend to underestimate or underreport the actual emissions that are happening. But one of the other cool features is that we can take the information that is in this gray bar, and then we can actually convert that instead of thinking about what the total emissions are happening, how much of them are coming from the industrial sector, how much of them are coming from transportation, how much are there from the shipping and the marine sector, et cetera. And we can kind of then come up with estimates over time. So in this figure here, I'm showing on the x-axis, or in the axis down here, I'm showing time progressing all the way from 2020. This is only just for a couple of years. And then I'm showing like the emission estimates for each of those different sectors. One of the cool features when we did the study that we found was that around March 2020, or between like March to May 2020, there was this huge dip that we noticed in the emissions from the transportation sector. And the reason for that was because of the COVID-19 lockdowns. And so the transportation sector, there was a complete stop, and there was a reduction in emissions that were happening. And we actually did pick that up in the satellite data. So again, this speaks to sort of the really powerful data set that we have, the highly accurate data that we have that can be used to do these type of analysis. So the carbon dioxide measurements that we take, that's our primary measurement from OCO2 and OCO3. But it turns out we have a second measurement, which was really kind of, we almost discovered it by luck in a little bit. But the second measurement that we have, it's called SIF, or solar-induced chlorophyll fluorescence for short, or for long. So what it really is that when sunlight is falling on leaves, most of the energy from the sunlight is used by the leaves for photosynthesis. Some of it is transmitted as heat, some of it can be reflected back, but it turns out that there is a very small signal in the red light spectrum that we can actually detect. And this particular signal turns out is a very important indicator for plant health. It is tied to how plants are taking up carbon dioxide and using them. And the healthier a plant is, or like happier and healthier a plant is, the more it's photosynthesizing, this signal actually tends to get stronger. And I have a great example here for the data that we have collected, for example, over Cairo, Egypt, where Cairo sits right at this crossroad between the more fertile Nile Delta, where there is a lot of vegetation, there's a lot of agriculture that's happening. And so you see the dark green on the northern side of Cairo. But then on the other side, you actually move out into sort of the reaches of the Sahara Desert. And so the SIF signal becomes like much brown or like yellow in this case, which basically means like it's barren land. And so with SIF, you can exactly pick up this gradients between where you have vegetation that's happy, that's healthy, that's like actually alive, whereas like where there is like no vegetation at all. And so this is again sort of an animation that just captures the SIF, showing like where the plants are taking up carbon and how it is doing. One of the things that you will notice is like if I keep on letting this movie play, again, you're seeing just like the orbit tracks, like this is actual data that we are taking from the satellites, that over the tropical regions, so for example, over the Amazon basin or over Africa and as well as over Indonesia, where we do know there are like really thick, dense forests, then you tend to see the SIF being darker green, higher in color, whereas like other regions, like for example, over the desert regions, etc., you kind of see that it's actually more barren. We also see changes as we go from the summer in the northern hemisphere when the plants are growing, and we see a stronger signal to like winter, etc. So there's like a lot of cool information that can be gleaned from this data set as well. And if you're really interested like in learning more about this, of course, I'm not being able to do justice to all the important details and the technical details as well as the science that's being done. I strongly encourage you to check out the Spacetime video that PBS put out back in September of last year. And it actually focuses on the SIF measurement that we have, how important or critical it is for looking at monitoring agriculture and looking at the impact of droughts on crops, as well as like doing forecasting for crop yield, looking at the impact of droughts and wildfires, etc. So it's a 12-minute video, but it's like really, really very well done. And we had worked closely to get all of the scientific and technical content, but just making sure that it is like easy to understand for like a wider audience. And sort of then zooming in closer to home, this is sort of like if we, instead of showing that global map of how the SIF data, the greenery looks, if we kind of just zoom in over the Los Angeles basin, then again, we see sort of like the darker over the darker green or the higher SIF over the Palos Verdes regions. And as well as you'll see like all these different pockets that kind of line up with different regions where we have parks, etc. We kind of were recently working in trying to further minimize the resolution of the data that we have and get into this very high resolution. And this is just one example that we did over the South El Monte region of the Whittier Narrows recreation area. So I think that would just be southeast where you all are. And again, it's kind of pretty amazing that using the information from the satellites and combining that with some other additional information about land cover types and everything, we are able to come up with this really high resolution maps of urban biodiversity, of the urban greenery, where all the green spaces are, etc. So the Los Angeles basin in general has been a really important testbed for OCO2, OCO3. As I said, one of our core validation network is at Caltech. And the two missions actually started as collaboration between JPL and Caltech and kind of grew from there. And so over time, there have been a lot of studies that we have done over Los Angeles. There is a very nice news article that was published by US Greenhouse Gas Center that was a collaboration previously between NASA, NOAA, and the Environmental Protection Agency. So all of that information, this is a very nice article that captures sort of the way the OCO2, OCO3 data can be used to look at different types of climate solutions over LA Basin. And one of the things that I actually don't have here, but I do want to mention is that periodically we actually do have interactions with different schools within the LA Basin. So for example, 2024, now not last year, 2025, 2024, we went out to the Southeast High School and we actually engaged and talked to a lot of the students there. They actually helped us do some artwork and animation for some of our videos. And then we also participated in sort of one of their Earth Science Forum or Earth Science Day to teach them more about climate change and CO2 monitoring and how those CO2-3 data can be helpful. So just kind of wrapping up here, OCO2 and OCO3, as I mentioned, are two of NASA's prime missions. And they're really part of this global observational network to sort of better understand changes in the carbon cycle and how it is evolving as climate is changing and atmospheric composition is changing. We now have a long record of data from the two missions and of course, really high precision and accuracy. And then the data from these two missions have been used to do a variety of studies. Again, I just mentioned like barely just not even one complete study, but just a little bit of the studies that have been done over Los Angeles. But there is like a whole spectrum of studies that have been done looking across the entire globe. And then finally, do want to give a huge shout out to the entire team that works tirelessly to make this happen. So I'm really, really honored to be presenting on their behalf and sort of representing the work of all these different team members. This is a photo from one of our science team meetings that we had on the Caltech campus. And with that, I'm happy to conclude just providing some more information on OCO2 and OCO3, as well as my email ID, and then an important colleague, again, who could not be present here today, her email ID as well. So I'm happy to answer questions now, but if there are any other thoughts or ideas or suggestions or questions that you have later on, then please reach out to us and we'd be happy to answer them. Thank you very much.
Thank you very much. I'll see if any of the commissioners have any questions.
A couple things, I guess. I just want to start by saying thank you, Dr. Chatterjee, for coming and speaking and giving this presentation. I think we spoke, it was now almost 2 years ago, And in the interim, there have been both the fires in Altadena, and then there was the government shutdown last year. And so I think during both of those periods, we were hoping to have you in and understand that there were more important things happening at the time.
Sure, yeah.
But I think for I guess the commission, for everyone, I hope to have you here really just because I think this is a remarkable work going on that you've been doing, you and the team. I think this is something that's worth highlighting just because of how close you are. You are our neighbor up to the Northeast, and I think it's a special opportunity to have someone like you come in and speak to the work that's going on at JPL. Some of your colleagues might even live in Glendale, for all we know. But to the work you're doing, I think it's, when I was thinking about it, it is very technical. It is very sophisticated data that you're producing. But it is interesting to think about how we as policymakers, as a local jurisdiction, can think about how to apply this information. I know that was a kind of an idea you were working with or are working on, thinking through, and you spoke to that a little bit at the end, but I think I don't have answers for that. I think it's something that will take time as this data is continued to be collected. As you said, there's sort of a verification that can be provided through this. So as policymakers implement new solutions, new strategies, we can look to this data and see how the emissions are changing, how things are looking within the region. What's remarkable, as you said, the kind of benefit of this mission has been looking at plant growth, photosynthesis, chlorophyll production. I saw some of the reporting come out last year about that, and I think that's pretty neat to have that kind of added benefit. So anyway, all that to say, thank you. I guess you did speak again a little bit to this, but are there some other examples of how this has been put to use and how small cities, for instance, like Glendale, relatively small, could make use of this? I mean, of course, this is kind of more this can be beneficial for the region, atmospheric CO2, it's mixing within the region and whatnot, but we are contributing to that. But, how can we as a city learn from your data and respond to it?
Again, and I just want to start by saying thank you again, Commissioner Bassmore, for the opportunity. I definitely enjoyed our discussions when we had it a couple of years back, and I'm really glad to be here. And certainly it's part of an ongoing conversation that we need to keep on having, right? Because as much as presenting some of these emissions and some of the data that we collect to you all, and collecting ideas and feedback from you, that helps us sort of refine our strategy and sort of the way that we present the data, the way that we talk about the data, and how that can be shared with a broader community. Certainly that definitely is the ultimate goal. Now, going to your question, recently we have had a couple of great examples. So the World Bank, one of the teams within World Bank, they have been using our data and to track how much emissions happen when cities switch from regular transportation to implementing a subway system. And they have released a couple of reports on this. They're a World Bank where they are using the data. They recently actually released one talking about emission estimates for different cities as well. Now, again, when these missions started and the data that we collected, we were very much focused on the global picture, and gradually over time, we have been refining our strategies to go from trying to understand things at the global scale to then going down to let's say over the entire North American continent to over the country scale. And then now with the SAM mode, we are able to drill down more into the local city scale. With CO2, you were absolutely right that the atmosphere keeps on mixing. And so it's the data that we collect over Glendale, some of that is carrying signature of, let's say, emissions that are happening over Glendale, but a lot of it might just be like air parcels that are coming in from, like, let's say, to the north or to the south, or if the wind is blowing from the Pacific Ocean, then it's carrying some information from, like, Malibu, for example, all the way up. So it's all kind of getting mixed. However, what I think the value will be is still that we have now developed tools where we can do some kind of what we call as downscaling of the data, or where we try to get a finer resolution with the data. And that uses not just the CO2 data from CO2, but it might use some additional information like nitrogen dioxide or carbon monoxide or methane, like some other atmospheric information from other satellite missions, and convolve all of them together and try to get at more of those local scale features, like even for like a city of the size of Glendale. The other one I think would be sort of the SIF data that I talked about, because we are again able to use the SIF data, but then combine that with information about the actual sort of the landscape and information from Google Earth Engine, in order to come up with like sort of these very high resolution maps of the urban greenery space. And if we keep on generating those maps over time, then you start picking up the trends of how that greenery space is changing, and whether that's being properly maintained and how it is changing over season, or if you have more rainfall over a particular season or not. So those are the types of information that I think are definitely really, really valuable. One of the other things that we have been discussing with the Los Angeles city, like with the mayor's office there, has been gearing up and preparing for the Olympics. So in a way, kind of trying to do some continuous monitoring around the entire LA basin, and then track those over time such that we are able to sort of get ready in time for the Olympics. And there are plans to sort of change the transportation system and other things, and what kind of an impact that might have on the net emissions in the basin. Again, I don't think it necessarily answers all the questions that you have, but I'm really still glad to start the discussion, and I hope to continue this in the future.
Absolutely, yes. No, and thank you. I think it is the start of a discussion. I hope this mission continues. I know there's some concerns around
Yes.
current appropriations from Congress. I think something came out this week, so about that. But I hope the missions, I hope there's an OCO4 maybe someday. But I think, yeah, hopefully years to come with this. One more thing, I know you showed briefly the Vulcan 3.0 data for kind of the emissions, like ground-based source estimates, I think is what it was.
Yes.
How does your work, how does the OCO data kind of interface with the Vulcan project and the data they're gathering?
Yeah, so that's a great question. And so the Vulcan project, which is coming primarily out of Arizona, university, one of the universities in Arizona, the way they gathered the data is based on different types of inventory and bookkeeping approaches. So they actually take stock of how many industries there are, how many cars are on the road, and combine all of that information and coming up with their estimates. We obviously are looking at the atmosphere, using that information to come up with our emission estimates. So hitherto, we have tried to keep them separate because they both sort of serve as a sanity check a little bit on each other. We are able to go back to the team that generates Vulcan and tell them that, hey, look, when we looked at, let's say, around like maybe 40 cities across the US, here are the list of cities where we think you are actually underreporting the emissions. Is there something that you can take a look at? And then they go back and take a look and maybe like, oh yes, we actually did not update this particular data, or we did not necessarily missed some information or something. And then the same for us is that, like, let's say we strongly overestimated, and then they are like, no, we are pretty certain that the emission estimates for Phoenix, let's say, is so much. You really need to check the data that you have collected, and maybe there were some errors in the data. So far right now, it has been like a sanity check on each of us. there are a growing number of those bottom-up emission estimates that are being generated, Vulcan being just one of them, but there are 4 or 5 of them out there. What we are finding is that when we do like a global comparison, we look at like cities across the globe, and we have done the study for like 175 cities across the globe. What we are finding is that typically for cities within North America or within Europe, so most of the developed nations, the bottom-up emission estimates you get from inventories like Vulcan, they are pretty accurate, they are pretty precise. However, when we are talking about cities over much of the global south, so over Southeast Asia or over Africa, there we see a huge discrepancy because some of those cities just don't have the capability to provide correct reporting. And it's not necessarily like they are in some cases, they're just completely missing sectors. And so that's where we feel we have actually, with the satellite data, we have been able to provide more of inputs to the inventory teams like Vulcan in sort of helping them identify sectors that they have completely missed or, emission estimates that were severely underreported.
Got it. Absolutely. That makes sense. And I ask because I know we as a city, as a part of our climate action and adaptation plan, we are, I think, every 5 years getting an emissions inventory for the city. I think that's coming from a third-party consultant, but it will be interesting to see those numbers and think about kind of the trend they're going, and potentially if the OCO data, the Vulcan data is available, to kind of see how maybe there's some possible alignment with that as the years go on. So.
Yeah. No, that is a great suggestion. I'd be more than happy to do that because, as I said, like Glendale, I mean, the city is not that small. So there is still we do get enough soundings where then in conjunction with information from other places, we can come up with estimates that are more covering the actual city definition, like the entire area. And then, yes, would be absolutely happy to report back on how that compares with some of the inventory-based estimates that are out there. So thank you for mentioning that. Yeah.
Excellent. Yeah, and I know I believe that's something that most cities that are adopting these climate action and adaptations plans, which there are many of in California, are all required to do. So that's maybe something on a more regional basis could be adopted or looked at. So yeah. Thank you.
Yeah, absolutely.
Yeah.
Thank you so much.
Thank you. And Commissioner Kurtunian, did you have questions? Okay. Anyone else? I did have a couple quick questions. So when they're doing the scans to collect the chlorophyll and photosynthesis information, is it done at a particular time of year when the trees are all, thriving, or is it done throughout the year and then they average it?
It is done throughout the year. So the way it works is that every time that, let's say, we are passing over Los Angeles, and this is where we are dependent upon our orbits, the satellite orbits, right, as they're passing over. Every time we are passing over, we are looking at Los Angeles Basin and collecting that data, and that data gets processed and is available. The biggest challenge that we have sometimes is clouds. And you all know how cloudy sometimes it can get in the region. So when we have clouds, then because we are looking at the reflected sunlight, there is just not enough sunlight for us to get those measurements. So that's why there are gaps in the data. And even if you, or later on, take a look or notice, as I was playing those animations, you would see all the orbits kind of dot line up, but then there would be a chunk missing. That's likely because of clouds that are there in that region. But no, we are collecting data all times a day. In some cases, we actually have been fortunate that with the space station orbits, at least, we have been able to see over Los Angeles 2 times a day. So we see it once in the morning pass, and then we saw it again later, at 3 p.m. or sometime in the afternoon. And so that information then is actually really helpful. And we have researchers who are trying to utilize that data set to better understand, for example, how does the emissions during the morning rush hour, how does that compare to the afternoon rush hour or the evening rush hour? are there any changes in them if you're looking across different cities, if you're looking across different seasons, etc.
Oh, thank you. I was just thinking of a presentation we got a few years ago that showed the CO2 emissions and how they changed, like in the fall when the leaves started falling, that you just notice this dramatic difference. And it really reminds us of just how much trees have to do with cleaning up these the pollutants and so on. So I was hoping that they get enough information that they could even identify what trees might be the most optimal to use, like maybe perhaps ones that are evergreen, that aren't deciduous or something like that, if they could get to that level of granularity.
Yeah, so we did not. So just with our data set alone from OCO2 or OCO3, we cannot get down to that granularity. That's a little bit hard. However, what we have recently been combining or doing has been combining the information from OCO2, OCO3 with some other information we get from our hyperspectral imagers. So out of JPL, we actually have an entire airborne hyperspectral imager called Avaris. And Avaris, that plane actually goes out and takes like these very detailed measurements of like almost each individual tree that is there across the basin. We can combine those two pieces of information, and then we can get at some of the questions like, okay, where we have some type of deciduous trees, or where we have the pine needles versus where maybe there's a little bit of agriculture happening, like more towards the northwest side of the basin. Like, how does the Avaris data compare with the OCO3 data, and what type of information we can get? So yeah, just ourselves, we won't be able to provide that information, but in conjunction with other data sets, then we certainly can.
Yeah, it'd be great for people, whether for their own landscaping or for municipalities when they're selecting street trees and so on, to know which ones would get the most bang for their buck in terms of climate cleanup. So well, thank you. Mm-hmm. And then the last question, I think Commissioner Bazemore was touching on this a little bit, but as far as the granularity at a city level, like would they be able to tell, for example, to what extent there's a disparity between like North Glendale and South Glendale, where there's a little bit more of a tree desert compared to North Glendale, where they have the mountains and wildland areas?
That is possible. That will require development of some new tools in order to be able to actually glean the information from that data. So that information is already sitting in the data, right? I think it's more on us as researchers, as scientists, that we haven't really tried to push ourselves to be able to extract information at that level, like almost what you are talking about here is essentially we are trying to come up with emission estimates like every couple of kilometers. It can certainly be done. It's just that's something that we haven't done. And so I'm going to make a note, and something that I'll try to have like my team and other external researchers within the academic community at Caltech and other places that we collaborate with, like present this as like both a challenge and an opportunity to them.
Great. Well, thank you so much. So last call for questions, for comments.
I have a question. Hi, as a high school student myself, when you mentioned that you collaborated with high school students, I was kind of curious if outreach was one of like your goals and how you collaborated with high school students to kind of reach that goal, if that is.
That is, yeah, so that's a great question. So I think this was started, it definitely outreach was one of the goals, and typically, or previously, not last year, but previously, JPL always does this one open day where we have different, like the entire community coming in, and people even travel from outside, like my family members have traveled from the Bay Area down here to come and visit JPL. The collaboration with the Southeast High School kind of actually started that way, where I think we had a group of students from that school visiting, and they got really excited, and we were discussing with the teachers who were accompanying the students, and that's how the collaboration started. I'm sorry, I really don't have the material here, but A lot of the work that we did was that the students, as they were learning more about the data, they were really, really interested in sort of doing some kind of artwork or animation. And we have actually released a couple of videos that are publicly available on YouTube, where the artwork from those students were actually incorporated in the video. And these are very simple YouTube videos talking about the measurements that we are taking, how the CO2 concentrations are changing, and how transportation or more cars contribute to it, how the trees are taking up carbon dioxide. But all of that artwork came from the students. And then we sort of did keep that communication going through 2020, like a couple of years. I think, again, it stopped for a variety of reasons last year. But if you have any ideas or if there are specific schools, we would be more than happy to, yes, absolutely come out and sort of do similar visits. I know we definitely do some work with the La Cañada Flint Ridge School, for example.
Oh yeah, that's just so amazing to hear. I think it's always great to have some digestible form of way for people like citizens and students to learn more about sustainability, especially complicated things like this system. I think it'd be great if we could outreach towards Glendale schools as well, if we're already collaborating with La Cañada Unified School District. And I'm sure we have a pretty strong robotics team both at Clark Magnet and at Crescenta Valley. And I think they'd love to hear more about your expertise and how they can get involved in just expanding outreach and making sure that students are aware of this as well.
Okay. Yeah, and I think I found like one of the videos, or what I can do is that I can certainly send it to Nora later on, like sort of the videos with the students' animation artwork. It was really cool. Like we were super impressed with how creative they were in terms of thinking about this. And I would be more than happy to, share that, and then you can take a look. But again, we'd be more than happy to absolutely come out and educate and teach more about this topic.
All right, thank you so much.
Thank you for the question.
Yes, thank you very much. And thank you for being willing to be contacted later for follow-up questions if anyone has any questions that they didn't think of already, or the folks at home if they have questions. So we appreciate that.
Absolutely. And again, thank you so much for the opportunity. I really appreciate it. Thank you all.
Yeah, thank you. Okay, next agenda item.
Thank you so much. So before we go to action items, we have Grant Michaels here from Glendale Homeowner Coordinating Council. He would like to present a certificate to Ms. Landergan, if it's permissible.
Yes, that would be fine. I know we intended to
Michaels?
have that be at the same time, but he was running a little late. So I'm a member of Glendale Homeowners Coordinating Council too, so
Thank you.
I'll join in at some point for the photo at least.
Good evening. I'm Grant Michaels, President of the Glendale Homeowners Coordinating Council. First, let me commend you for your efficiency in running meetings on time. I do know how difficult that is, and I appreciate the time for us to acknowledge Stephanie Landrigan and her efforts. In my tenure with the city, coming before you, I've lost track of the number of times that I've appeared before you and the various commissions that you were on. So very briefly, on behalf of the Glendale Homeowners Coordinating Council, we would like to present Stephanie Landrigan with a certificate of appreciation. And if I can impose upon you to come down and join me for a photograph with Ms. Landrigan, I would appreciate that.
Great, thank you. Yeah, let's all join in. The more the merrier.
Well, this is well-deserved and well-earned. So,
I know, sorry. It's hard having two first names, isn't it?
no problem. But hopefully this is just a small token of our appreciation for all that you have done.
Okay, thank you. Thank you.
Okay.
First, for our website when we ever get around to developing one.
Well deserved, Stephanie.
Thank you.
And then
And
everyone else?
as proof for it all to happen, if the commissioners could join us.
The commission is a. Thank you so much, and again,
Thank you
congratulations,
again.
and really appreciate your
You all
efforts.
were really helpful in all of your letters. Thank you so much.
I wanted to make sure we got a chance to just appreciate you. I'm sure many nice things were said, and I appreciate you staying around for this. Thank you.
Thank you. I'm very honored. Thank you.
Thank you. Next item on the agenda is action item 5A, approval of the Sustainability Commission's 2026-27 work plan. Motion to approve the 2026-27 Sustainability Work Plan. Thank you.
Good evening, Commissioners. This will be our presentation for the work plan. As you all know, we met last month to discuss the items and to go over the 2025 work plan. In this meeting, we will be reviewing the items left over and considering adoption of the 2026 work plan. So as you recall, our recommendation is to stay within these 5 focus areas. In doing so, our items would be as follows. There were 3 modifications that were proposed during the last meeting. This was to acknowledge that the demand response item would be the new demand response item, and that to consider zone 0 regulations within fire setbacks as well. And the other modification was to ensure that AB 1572 was also reviewed. This was the overarching regulation that was encompassing the Lose the Lawn campaign. So we made modifications to those 3 items, and then we also added an asterisk next to the items that were completed but are continuous for the next year too. So if you see an asterisk in the outreach and engagement column, that's what that indicates. And same goes for the review green waste diversion programs and consider options for improving adherence to SB 1383. This is the 2026 work plan as it stands. And if you would have any questions or if you have any more changes that you'd like to do, we can make those changes before approving the work plan. Thank you.
Yeah, I wanted to ask, what is AB 1572 again?
That was the regulation that was brought up by Vice Chair Pinkerton, and then during the last meeting, Commissioner Kartunian mentioned it too. This was the regulation that we wanted to more closely look into. It was regarding non-functional turf.
Well, and not using potable water for irrigation in general.
Correct, yeah.
Got it. Okay. So I guess if that could be just added on to that, might be beneficial for, you know, anyone looking at our work plan as a reminder for us. It's not like going to make or break it for me, but, you know, if we could just say like review, you know, the turf and water considerations in AB 1572 or something. I don't know.
Yeah, it should, I mean, to your point, like, not everyone knows all these by heart, so,
Yeah.
where it's clear, where usually these have some kind of nickname, like, you know, the Lose the Lawn thing or something like that. So something that makes it clear for people looking at it, you know, without having to go Google it to see which ordinance that is.
Madam Chair, members of the commission, I can provide just a little bit of overview for the commission and anyone who's watching. So it bans the use of drinking water, potable water for non-functional turf, decorative grass, and commercial, industrial, and institutional zones, as well as on HOA properties, phasing in requirements starting on January 1st of 2027. For state and local properties, so governmental properties. Then in 2028 for the commercial, industrial, and institutional zones, and 2029 for HOAs. with exceptions for functional turf, parks, homes, and specific tree shrub needs, aiming to conserve water by replacing ornamental grass with drought-tolerant landscaping. That's the overview with a phase-in. Hopefully that's useful.
Thank you.
And specifically, we can go a step farther. Instead of just naming the title, is the concern that we brought up last time is compliance, the options that residents have to comply with AB 1572. What are different avenues for them?
So it doesn't apply to residential, though, right?
It would apply ultimately in 2029 to homeowners associations, so yes.
Right, for their common area spaces, so.
That's correct.
Yeah, which we don't have a ton of in Glendale, but yeah, I see your point there. But people would want to know, yeah, how does this affect me, and do I need to, you know,
Or commercial lots that have lawns, that have greenery.
yeah.
One of the ways the city has addressed issues such as this, where information is critically important in terms of compliance, is to publish a fact sheet and to provide that information on GTV6 as well, where residents and owners of businesses can get more information.
Well, thank you, because there is some concern if single-family homeowners thought it applied to them, they'd be wondering where they're going to get non-potable water. So yeah, okay, thank you. So were there any other questions or comments on that?
Just a question about that, because I know me and Jennifer talked about this recently. Would schools fall under the 2027 time limit because they're government-owned, like public schools? Yeah?
I would think so.
That's
We'd have to check into that. I'm just providing the overview, but that's a very good question.
Yeah, it could fall under institutional even, so it's hard
Yeah.
to tell. I know schools are a little different sometimes than,
I know she mentioned that she wanted like students to collaborate on maybe like transforming like the turf on school properties that we have. So that's just a quick question.
Ideally, you would have to refer back to the full bill to see if there's any exemptions provided for schools. On a lot of these bills, at the 11th hour, they'll put in exemptions for this kind of property or that kind of property.
If I may address the exemption issue and the overview, and you're correct, we need to review the language, specific language of the bill. What's specifically exempted are residential yards, cemeteries, parks, golf courses, sports fields, watering trees, and non-turf plants. But it doesn't mention schools, so we need to take a look at that.
right, thank you. And it's non-functional ones, so if a school could have areas, like a recreational spot would be considered functional, but it may be some other area wouldn't, and that kind of thing. But even though these timeframes to phase them in seem really far away, they should be planning now so that these trees can get, or shrubs or what have you, the drought-tolerant plant material can take hold while they can still irrigate, so that later when they remove the irrigation, they don't just die right away. So it's something they need to be thinking about now and not waiting until it's, the deadline is upon them.
It sounds like we would like to change the name to say review AB 1572 non-functional turf compliance.
Well, and non-potable water or potable water irrigation ban, compliance, something like that. But
I would say refer to the official title.
yeah, whatever they're calling it, because usually there's something.
Compliance with whatever the title is.
Since it applies to more than just turf. So
May I please have a motion and second?
Do we have the title handy? Is there a title?
What I'm seeing online is non-functional turf irrigation regulation or regulations.
Okay, so it would be review compliance with what was stated,
The non-functional turf irrigation regulations.
and then maybe in
AB
like
1572.
brackets the title, or the Assembly Bill number.
Will do.
Okay, does anyone have any other questions or clarifying comments or anything before we consider this for a vote? Okay, it looks like do you feel comfortable voting or do you have another question? Okay, just want to make sure. All right, so it looks like we're ready for roll call.
Would someone like to move?
Oh, yeah, details, no.
I will move to approve the work plan, 2026 work plan with the amendments just stated for the one item.
Second?
I'll second it. Or you second?
I seconded first.
Okay. Commissioners Bazemore,
Yes.
Artunian,
Yes.
Chakarian,
Yes.
Vice Chair Pinkerton, and Chair Werner.
Yes.
Thank you. Item number 7, Sustainability Office updates.
We have just one small update. This Saturday, there will be a Composting 101 workshop hosted by LA County Public Works. It's going to be at Glendale Central Library from 10:30 a.m. till 12 p.m. If anyone would like to join, there's no need to RSVP. Anyone can go.
Is this part of the, I know the city has hired LA Compost to assist with composting work in, the initiative in Glendale. Are they involved with the county in this effort, or is this sort of a separate thing that the county's doing?
This is a separate county program. It's called Clean LA, and they've been hosting workshops in different cities, and they're just coming around to Glendale.
Got it.
But
Oh,
it's
there we go.
connected to 1383 probably because, we're expected to buy compost and distribute it. So, okay.
Great. Thank you.
Next item on the agenda is adjournment. May I please have a motion and second?
All right. What about, so we don't have any callers for public comment or anything?
Oh, we don't have any callers.
Okay.
No
Okay.
public comments.
So,
either.
yeah, I'm willing to entertain a motion for adjournment.
I'll move to adjourn.
And we're adjourned at 6:50 p.m. Thank you.
Okay, thank you.
Off key in my chorus.